And with this, let us recap what we did in our morning session. First, for recap, can anyone come up on the mic and tell us what we did on the morning session? Anyone? Just a quick recap.
Yeah, in morning session, actually, we were talking about PLCs and different component of PLC, what is a microcontroller, and so on.
Yeah, so we were talking about PLC, how PLC are deployed on a OT environment, how it is used to run an industrial control system. So with that being said, I think now most of you are aware of the anatomy of how an industrial control system works, where the PLCs are present, where is the SCADA system present in the network, how the segmentation is done, and how the field devices are controlled with this PLCs. And irrespective to the domain, use case is going to be the same. So let's say you have a IoT farm where you are irrigating your crops remotely from a MQTT server. It is again connected to the same PLC in the device end, and that PLC is connected to your SCADA systems, and your SCADA system is connected to the MQTT server from where you can connect the control the irrigation system. Okay, with that being said, let's understand how PLCs are connected in a power grid. And for that, I think I have told you guys how uh, PLCs are connected in NTPC, how each and every turbine is connected to a single PLC, and we can regulate the amount of voltage being given to the grids. We can regulate how turbines are being operated. We can see how much voltage is generated. This is a simple HMI that you can see on my screen. Please let me know if my screen is visible.
Yes, it is.
Yeah. So this is a HMI which is used to control your PLCs. So it's uh, it's usual that these generators and transformers possess a very high voltage, which is why they are connected to PLCs, and we don't usually go to the transformers and check for the voltages and toggle switches near transformers, because that might be dangerous. So in such huge power grids, we have PLCs deployed, and sometimes these grids are really very large. Let's take a solar power grid, for example. It is spread into acres. So uh, in that grid, there is a matrix divided, and from there, each and every coordinate will represent a solar panel, and that will be again showed in your HMI. Okay, so here this HMI is basically uh, a human to machine interface from where you can see what is being done and what is happening inside your plant, and you can control the field devices from here. So as you can see, there is a PLC that is defined as generator here. Okay, and then this is connected to BRK1. This is another PLC that is giving us a continuity of generator current, and then it is connected to 400 kilovolt bus, which is again connected to a transformer, and from this transformer we get electricity. Okay, so electricity is transferred to the substation here. Okay, so this is how your HMI looks. Okay, and once we start the generator, once I toggle the button start generator, you can see the event log here which says generator has been started, operator started generator. Okay, and you can see the voltage difference here. And if I stop the generator, it says operator stop the generator. Okay. And RTU connected, the remote terminal unit that is connected there, is now disconnected because the generator is stopped. So there is no live scanning. So when I start the generator, it says the RTU unit is again connected. And in such kind of SCADA systems, we have multiple alarms. Okay. So if we try to inject a fault, it says the transmission is now healthy. But if there is a fault, we should understand at which coordinate the transmission line is corrupted or where the transmission line is interrupted, which is why these PLCs are deployed as a matrix so that we can identify at which area the transmission line is at fault. So if I inject a fault from here, you can see there is a alarm coming on saying that transmission fault detected and our substation is getting no power. Okay. So yeah, we can try alarms as well. So these PLCs are again connected to many continuity sensors, which ensure that transmission lines are not interrupted in between. And if I clear the fault, it says no alarm active. And then BRK1 is our breaker. So if the breaker is closed, then it is transferring electricity. And if I open the breaker, that means this is basically acting as a relay. So if I open the breaker, now the transmission is stopped. So substation load is zero now. So yeah, so if you have access to this machine, human to machine interface, you can in short control your whole power substation. And from here, if you are monitoring or if you are an attacker and if you can read the Modbus signals from here, so you can replicate the same Modbus signal to open and close the breaker, and you can uh, perform malicious activity here, or you can temporarily stop the substation or stop the HMI to be presented to the users there. So we can have a ransomware attack as well, or we can explicitly increase the voltage, or we can alter the transformer values as well. So this can cause a very big damage. So this is how your HMI controls your ICS environment. And in order to protect your ICS environments, this has to be in a perfect segment of network where your attacker cannot operate. And if your attacker is inside this network, he should be seeing a few honeypots so that this communication protocol remains confidential. Okay. And there are a few third-party softwares as well that can help you encrypt these Modbus registers. So any doubts still here? Hello? Am I audible?
Yes, Sushant.
Yeah, so are there any doubts? No. Okay. So with this being said, you can let me know if you're having any doubt here, because we are going to understand a very good case study here. It's a 2015 Ukraine power grid attack, and it's very interesting story. So if you understand this, then and only then you can relate to that. And when I tell you the story, you will understand what has happened there. Okay. So I assume that there are no doubts, and the HMI was self-explanatory. So I think we should start with the 2015 Ukraine power grid attack. Okay. Okay. So this was a attack on power grid uh, in 2015, and this attack was carried out in two different ways here. Okay. One way was the sneaky computer attack, where the attacker attacked the human to machine interface, and it was a phishing sort of attack. And there was another attack that was a loud physical attack where they were attacking uh, using rockets and flying drones to hit the spots of the power grid. Okay, so let's start with the sneaky computer attack. And this is very interesting. So this is the attack process flowchart. So imagine a group of bad guys wanting to turn off the lights in the whole city, but they don't want to show up in person. Instead, they use these computers. Okay, so you want to turn off and on and off the lights inside the cities, but you don't want to do it physically. You want to do it as anonymously. So you use these computers. So this is how they started. The attackers sent fake emails to people who work at the power company. These emails looked real, like an update from a boss, but they had a hidden computer bug inside. Okay. And I think most of you are aware of phishing emails. Yeah. Is phishing concept clear with you guys? Okay. Yeah. So yeah. So they sent an email and there was a bug inside. And this is what happened actually. When someone clicked on the email, the bug, it was a kind of software virus secretly stuck inside the company's computer system. And the taking over phase was the attackers could then see the control, what the workers saw on their screens. They found the master controls of the power grid and with a few clicks turned off the of country. So it was very different. They had access to the human to machine interface and they can alter the grids, and with a few clicks they turned off power to the very big sections of country. And it was very hard to fix actually. To make things worse, they also used a trick to erase important files on the company's computers, like deleting a map of all the switches. This made it really hard for the workers to figure out what was wrong. And it was a very notorious attack. And they turned the power back on. They even made the customer service phones ring nonstop with fake calls so that people couldn't report the outrage. So it was the computer attack phase, and it was very different sort of attack. And we haven't seen such kind of attack in industry lately. And this was in 2015. And the loud physical attack was different. This is more like someone taking a baseball bat and they were hitting the electricity office. So the attacker used flying drones to hit key spots on the power grid. They aimed for big important buildings called the substations. Inside these buildings there are giant boxes, and these boxes were are transformers, and that are super important for moving power around. So all the step up transformers were damaged, and when a rocket or drone hits the transformer, it blows up and breaks because these transformers are oil based transformers. And it was very difficult to replace these transformers. And the result was, by breaking these parts, the attackers wanted to cause a huge and long lasting breakpoint, especially during the cold winter. And the goal was to make people's life miserable. No heat, no running water, no way to charge a phone. So it was very planned attack. And the two-part attack was like they corrupted, they stopped the power grid, they stopped the power substation, and then they were attacking on the transformers. And it caused a very big breakdown. So yeah, this started from a phishing email, and this is how harmful an ICS attack can be. Well, there are very few attacks that happen though, but yeah, if such kind of attacks happen, there's a very big destruction. And I hope this is clear with you guys. And or if you have any doubts, you can ask me now, like regarding the details. Yeah. Hello.
Uh,
Am I audible?
yes, Sushant, you are audible. I really request everyone that now you guys have an option to unmute
Yeah, you
yourself.
can turn on your mic and we can make the session into a conversation.
Interactive.
We can understand what actually happened in this attack because this is very important. So the fake emails part was the first step actually. They sent fake emails to employees at the power company, and these emails were designed to look very real, often pretending to be from a colleague or a manager or a trusted company. The emails might say something like, please open the document for software update. And the document was having a Trojan horse. I think you guys are aware of Trojan horse as well. Yeah, this is a very basic malware. Yeah. Yeah, so the email had this file, and the file wasn't what it claimed to be, though. And the file looks very harmless, but contained hidden piece of software. And this software was the malware. And when employee opened an attachment, the malware secretly installed itself in their computers without them even knowing. I think have you guys gone through Metasploit framework during this session? Yeah, yeah. So similarly, how Metasploit is designed, there are like, have you guys tried creating a Windows meterpreter malware in Metasploit? Hello?
They have briefly gone through those meter preter and that all other operations, but I'm not
Okay.
sure.
Okay. So there,
Hands-on one.
okay, you have just saw there was no, okay, there was no hands-on. So all these malwares are very good at creating backdoors actually. So uh, when it comes to Windows meterpreter malware as well, it creates a reverse TCP shell from your computer to the attacker's computer. So even if you have a firewall turned on in between, it cannot block the reverse TCP communication because it's the owner. Hey, the owner, the workstation itself wants to establish a communication with attackers. So from this, uh, you cannot stop this communication because firewall will only stop your TCP communication because that those are only the default policies that are set up in your firewall. So it 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 cannot stop a reverse TCP connection. Are you guys aware of TCP and reverse TCP communication protocols? Hmm? Yeah. So it was a similar kind of malware. So yeah, so this was about our Ukraine power grid attack, and it was a, yeah, as the methodology states, it was a multi-stage attack process. They had a physical and digital attack as well. So Yeah, I think we are wrapping up with the Ukraine power grid attack. And now we will have of our Stuxnet attack, and then we'll jump to the labs. So I think this is clear with you guys. Let me just quickly start with the Stuxnet. Just a minute. This was the X malware. You can ask if you have any questions. Or shall I proceed with Stuxnet?
Yeah, please proceed, Sushant.
Yeah, okay, done. So events Stuxnet is a part of your lab today. So how are you guys aware of the story? What happened actually? Let me know, or else we can start with the storyline first. Yeah. No. Okay. So for those who don't know what happened actually, this is the this was a very unique attack where government agencies were involved, and even president of USA was involved in this attack. So we can start with the briefing first. So the Stuxnet attack is a very famous example of cyber attack, and it was designed to cause a physical damage, not just a disrupt to computer networks. It was a groundbreaking attack, and it was highly sophisticated operation. It has a very streamlined approach. So for you guys, just think of Iran's nuclear program as a high security factory that uses special machines called centrifugals. Okay. So Iran was conducting this nuclear test, and it had multiple centrifugals inside its nuclear plant. And these centrifugals were again, uh, they 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 were filled with uranium, and these centrifugals were controlled by PLCs again. Okay, so just think that these centrifugals were targeted in the attack. Okay, so these centrifugals were used to etch uranium. Okay, I hope you can understand how uranium is enriched using these centrifugals. And if not, it's a very, you know, usual thing. I don't think we should stress on it. But for starters, just understand that this machine spins incredible. It spins very fast, and to be honest, it is incredibly fast. And these machines are controlled by computers. So all these different centrifugals are connected by PLCs, and they are then controlled by computers. And the factory is totally air gapped. You know what's the meaning of air gap here? Yeah,
I think they have gone through this air gap means that sandboxing kind of thing. They might already in Malware
exactly.
Analysis
So yeah, it
have already
means
gone
that
through.
the computer network is not connected to internet. Okay. Air, yeah, isolation of network, exactly. So the factory was air gapped, which made it very difficult to get inside the computers. And air gapping is not only used in cybersecurity. There are many companies that use um, cracked softwares. There are many designing companies that used cracked softwares. I was working for this company 3 years back, and it was a jewelry CAD design company, and we were doing the networking there. So that company had a CAD department which was air gapped because they were using cracked softwares, and these machines are not allowed to be connected to the internet, because once they are deployed on internet, they will go and check for license, and this is a problem. So air gapping is a mechanism that isolates your computer network from the internet. So if there's no internet, then it's very hard for the authorities to get inside the computers and actually know. And this nuclear power plant was like, this nuclear testing was very secret, and it was very dangerous for the world as well, and they were doing it secretly. So there were agents deployed. Okay, so for us, let's understand that these centrifugals are connected to PLCs, and these PLCs are connected to computers, and these centrifugals are the only way to enrich uranium there, and they spin incredibly fast, and the spin rotation is controlled by the human to machine interface. Am I clear till here? Yeah. Yeah, okay. So the attackers, widely believed to be the US and Israel, and they had to, like, we like, most of the people know that it was US and Israel administrations, but they have never claimed it to be them. So, so they had to figure out a way to get a virus inside this air-gapped factory, and it was very hard. So I, one of you to tell me that how can we inject a virus inside a air-gapped factory here? Like, let's assume all of you are a part of my agency, and we have to fill we have to deploy a malware inside those air gapped computers in order to destroy those centrifugals and to stop their testing, because once this testing is done, then our national security is at risk. So as a part of individual, what would you guys do? How would you find out a way? Hmm? Come on, guys, open up your mics and uh, try to make it more interactive, so that your participation is very important here, so that you can understand the concept. Yeah, anyone? As per you, PLC injection, uh, can you please elaborate? What do you mean by PLC injection here? Yeah, you cannot you cannot email the virus, you cannot use phishing, you cannot get inside their network. Inject Malware is injected while testing phase. Okay, so you mean that you would inject malware while the, yeah, exactly. This is the main aim, to inject the malware while the testing is done. So during the testing phase, we want to inject the malware, but how do we get inside this air gap security? This is my concern. What would you guys do? Come on, don't think. This is very easy approach actually. So just imagine that since the factory is air gapped, we cannot just send email viruses. So we had to use a very common, yeah, exactly, USBs, pen drives. Yeah. So how do we inject these USBs? So now that the network is air gapped, we have to figure out a way to inject these USB drives inside your social engineering for the employees. Exactly, Mukul. Yeah, exactly. So US and Israel trained agents to uh, you know inject these USB drives inside their systems. And there are two kind of USB attacks. Okay, one is basically uh, putting the USB stick inside your system and then manually turning on the USB, like going to the files and executing the bat file so that it can change the configurations and it can create a backdoor. So this is a very manual way. Or there is another way, which is called HID attack. So HID attack, basically your USB flash drives are not ordinary flash drives. These flash drives are connected to your systems and they are recognized as human to machine interface devices. So they have HID interfaces. Your whenever you connect your mouse to your computer, your mouse connects as a HID device, human interface device. Whenever you connect your keyboard, it connects as a HID device. So this kind of pen drive is also connected and it connects as a HID device. And when you connect this pen drive, it automatically types keystrokes inside your command prompt to turn off the Windows enabled firewalls, and it can execute the malware and it can create backdoor within 15 seconds. I think you guys might be aware of this rubber ducky. Are you aware of this? Yeah. No. So Manish, rubber ducky is basically a device. Okay, let me show you what a rubber ducky is. Okay. So this is the company HackFi, which manufactures rubber ducky. Okay. This is how rubber ducky looks like. Okay. Yeah. It looks like a normal USB flash drive, but internally it has Attitiny 85. Attitiny 85 is again a microcontroller that has capability of injecting itself as a human interface device. Okay, so this human interface, this micro SD card contains your payload. I think you guys are familiar with these terms: payload, malware, and the yeah, exactly. So this uh, flash drive takes the payload from your SD card, and when you inject this, firstly it detects your operating system. So it is very important for a scripter to make this payload uh, compatible for multiple OS. So if it is being injected in Debian, the Debian function of the commands should come up. If it detects for Windows, the Windows function should come up. So these rubber ducky scripts are coded again in C, C++. Mostly it's MicroPython is used. Okay. So there are predefined scripts as well. Okay. So you can like these device with these devices, you don't need to do anything. Okay. So for example, you can go inside the office and you can just inject this rubber ducky and walk around for 15 seconds and then take the device and then go away. No one would notice what has happened. Okay. And there are few cables as well. Let me show you. Rubber ducky data cable. Okay. So there are a few data cables. It's called OMG Elite. Okay. So these cables are also, they also work as a rubber ducky. So for example, if I want to deploy a malware inside your computer and if I want to take access to your computer, I will come to you and say, hey, sir, let me charge your phone from your computer. A very simple social engineering attack, and I will pull out my data cable. I will give it to you guys. And once you inject the data cable inside your system, my phone is being charged, but in the back end for 15 seconds, your system is being controlled by my OMG Elite, and then backdoor is created, and I can go back and take access to your computer. So yeah, these these are two different kinds of attacks. Okay, one is scripting a malware, deploying that malware inside your USB and taking access to the computer for 5 to 6 minutes and trying to, you know, infect the computer with your malware by your interface. And if not, you can use these automated USB drives, which we call as OMG allied cables or rubber duckies. Or you can buy, if you don't want to spend so much money in buying such cables, you can simply buy Tiny 85. Tiny 85 is a very nice microcontroller. Okay, it cost you around 222 rupees. Okay, and this is manufactured by a company called DigiSpark, and this can be used for the same. Okay, so Tiny 85 rubber ducky GitHub. If you type rubber ducky GitHub, there are few predefined scripts. You can install these scripts inside your Tiny 85 and you can see how it works. And again, this is just for educational purpose. Okay, so I don't want you to hack inside someone's system using these devices. But yeah, if a normal security researcher would want to do, they would buy it for $180. But since I know what is inside these cables, I can simply buy this Tiny 85 microcontroller, and this microcontroller comes with a USB interface already. But yeah, so this is the only way. So since the network is air gapped, we have to use a USB stick. So actually what happened was the attackers created a super smart virus, and they put it inside the infected USB flash drive, and this USB drive was likely given to an employee or a contractor who worked at the nuclear facility, and the chain of injection was carried out differently when the unsuspecting person plugged. So what you basically do is uh, you can throw these USB devices in a bunch on road, and you can see if someone picks it up and if they try to put it inside their system to see what is inside this, and they'll see there's nothing inside, but in the back end they are being infected by the malware. So yeah, so this is again a very creative way of exploiting. They targeted a unsuspecting person, and they plugged the USB stick into the computer inside factory, and the virus immediately copied itself onto that computer. Then it looked for other computers on the same local network. Okay, so let's say this is why network segregation is important, because if departments are not segmented properly, then if one computer is infected, it can easily spread inside other computers as well. So before executing the malware, the first phase of this malware was to spread inside the entire local network. Okay, and it copied itself in them too, and it was designed to jump from one computer to another computer until it finds its real target. Okay, so there were specific parameters to determine whether this computer is your target or not. So once the factory's network, uh, the Stuxnet was like a typical virus and it was spreading everywhere. So once it was totally inside the network and inside each and every systems, there was this terminology called DNA check. The virus was programmed to look for very specific signals, and it ignored every computer that wasn't running a particular software in the company. And the software was called Siemens S7. Okay. So this software, like they were searching for this specific software because only from that software they can control the HMI. And if computers having Siemens software can only be connected to the PLC, so they were searching for this specific software, and this software is used to control the industrial equipments there. So as I told you that Siemens have their proprietary softwares as well, and including the centrifugals. So as I told you, these centrifugals were inside the factory's network. So the right blueprint was very important. And even after finding the Siemens software, Stuxnet didn't act. Okay, this is the main planning. So after finding the Siemens software, it still didn't act, and it also looked for a specific blueprint and a set of instructions basically that matched exact setup of the centrifugals at the factory. So only when it found the exact match, it would move on to the next step. Okay, so until the exact match is not found, it won't be moved to the next step. But you might be having a question that how does the attacker know that there are centrifugals placed inside the company? They are using centrifugals to enrich uranium. So this was not a 1 week or 2 day attack. So it was a very big attack, and it was there were many agents deployed there, and they were collecting intels and giving it to the companies, to the government agencies where they were creating this malware. So, and the sabotage period was very important. The virus took over the controls of the centrifugals and it began to change their spinning speed. This was very important. Once all the conditions were satisfied, they began to change the spinning speed of the centrifugals, making them spin too fast and then too slow over and over again. This was a slow, subtle change designed to wear out the damage and machines over time. So it was vigorously increasing the speed and then bringing it back to zero. So till here, I think everything is clear. What happened? Yeah. Yeah. So coming to the main part. Yeah. So the cleverest part of the attack was that Stuxnet also created a fake reality for people watching the computers. So these encoders, so basically, uh, in a moving motor or in a rotary actuator, when you rotate, there are a few rotary encoders. So rotary encoders are basically uh, devices that tells you what is the speed at which your motors are rotating or your centrifugals are spinning. Okay, so they surpassed this encoder's value, and they found, like, they constructed an entire blueprint and they were sending fake encoded values to the HMIs, and people watching the computers, they didn't know what is actually happening in the plant. So on the screens in the control room, everything looked normal, and computers reported that centrifugals were spinning at correct speed as well, and workers had no idea that their machines were being secretly sabotaged there. Okay, and the outcome was also very interesting. Stuxnet attack had a very huge success for its creators, basically, and coming to the physical damage is was very big actually. The attack reportedly destroyed about fifth of the centrifugals at the factory, and this wasn't a quick explosion but a gradual. So it was a very slow motion destruction, and they were delaying the program. The damage set in Iran's nuclear program back by estimated it was almost around 2 years. Okay, so they have almost delayed it to 2 years so that people would think that it is a technical failure. So they were gradually increasing and decreasing at the same time. And the big reveal was like the whole thing was only discovered when the centrifugal started breaking down, and at an usually high rate. So engineers couldn't basically figure out why, and until they found out the Stuxnet virus, they figured out its very sophisticated plan, and it was a game changer, Stuxnet, and it showed the world that computer virus could be a physical weapon, not just a digital one. And it was very precise and targeted attack that demonstrated a level of warfare. But the Stuxnet attack, this malware didn't stop here. This malware was spreading beyond. There were many other facilities. There were many power grids that faced the same attack. There were manufacturing plants that were having the same attack, because once a malware is introduced to the industry, to the community, you have a PPT kindly explain things through that. Otherwise, it makes very less sense to the audience. Going in very 1 second. So you want a PPT for explaining the attack? Actually, I was explaining you the story that we know. Okay. And let me just go back. Let's see if we have anything. There's a documentary actually for this Stuxnet attack. Okay. One second. So I think if you want to know in detail about the Stuxnet attack, there is a full documentary on Stuxnet attack. It's called 0 Days. Okay. I think you can see this documentary, and everything is documented here because we don't have time to understand each and every concept. But I think the terminology that I have explained sums up the anatomy of how the attack was carried. It was carried by using a flash drive, and they were mapping the HMI to show fake values, and they were changing the turbine values from 0 to 100 analog percentage again and again. So this was exactly what happened. And over the time, over 2 years of time, they were able to destroy all the centrifugals, and then you know, uh, Stuxnet was introduced to the scene. So we have the Stuxnet lab demonstration for you guys. So I think instead of showing that, we can see the lab as well. Okay, 1 second. This is our lab. So we will demonstrate how the Stuxnet attack was carried out in your online lab. But please let me know till here. Is it clear what happened in the Stuxnet attack, so that we can take a quick break and then start with the lab sessions? Okay, so yeah, okay. So now that you know what exactly happened in the Stuxnet attack, we can jump towards the online lab and we can try to perform that attack. And this will give you a clear information on what exactly happened. And during this time, I will give you this links. Okay, I will provide this link in the chat box, and I hope you got your email usernames and passwords. Okay, so we'll take a quick break, and after the break we will start with the lab session. Okay, there are total of 4 labs that we have to complete, and once we complete the lab, we can the system generates your certificate. And I hope by the end of all these 4 labs you will have exposure to industrial control system security. And if you want to understand about the specifications of the malware which was exploited during this, you can connect to us afterward, so that we can have we can send you a documentation on that. But relevance to this workshop, I think information given is enough. And so Vikasji, we will go for a small break, and then I hope that you have